In this video, I'm going to show you how to set up a WireGuard private VPN. Lots of reasons to use WireGuard. It's fast, modern, and secure. I'll cover more of the options later in this video, but in brief, minimal attack surface using this, modern cryptography is used, there are no leaky logs by default, self-hosting gives you full control, you run the server so no third party can see or log your connection times, IP addresses, or DNS requests. You could combine it with a Pi-hole server or DNS crypt server for full stack network privacy. It also gives you stealth and port agility, can be configured to run on any UDP port, making it harder to fingerprint. So many reasons to use WireGuard. Now I'm going to show you how to set up WireGuard really quickly. Have a look at the timestamps in this video if you want to see how to lock down your server. You must lock down your server. So as an example, disable SSH access using root and using passwords. You want to make sure that your server isn't easy to hack. But that's not what I'm going to demonstrate here. In this part of the video, I'm simply going to show you how to get WireGuard up and running really quickly. I'm going to use a server on Linode, or Akamai as it's known these days since the acquisition. This is not a sponsored video. This is simply a solution that I like to use. I'm going to be running the server on Linode and then the client software on this Windows laptop. I'm also going to show you some tricks. As an example, be careful with IPv6. Your IP address will be exposed to the internet. So I'm going to show you how to disable IPv6 on this laptop as an example, so that we are only sending traffic using IPv4 and that it's NATed by our server in the cloud. Okay, so first thing I'm going to do is create a new Linode. I need to specify region. I'll simply specify Dallas. I'm going to use Ubuntu. You can decide on the size of your server and the amount of bandwidth that you need. So dedicated server gives you 40 gigabits per second in, 4 gigabits per second out, but that costs $36 a month. Very expensive options available here. I don't need those kinds of speeds. So I'm going to go to shared server and I'm going to select a 2 gig server. I mean, that's big enough for me. 40 gig in, 2 gig out. My internet connection here is only 1 gig on fiber. And for this demonstration, I'm actually going to be using Starlink. Doesn't give me those kinds of speeds. So I could probably get away with a 1 gig server. But for this example, I'll select 2 gig. And scrolling down, I can specify my server. So I'm going to say David VPN demo. It's an Ubuntu US central server. I need to specify a root password. So I'll specify my password and then I'll create the Linode. So this basically creates a server. Here's the IP address of the server. That's how I SSH to the server. So SSH root. Remember, you're going to probably want to disable root access and use public and private keys. So again, I'll show you how to do that later in the video. But for the moment, I'll simply SSH to the server using root, get my WireGuard VPN setup, and then we'll look at locking down the server. So as always, I'm too impatient. The server is booting, so I need to wait for that. Okay, it's actually running now, but it takes a while before I get access, so I won't bore you too much, but basically you just need to make sure that you have connectivity to your server and make sure that you can SSH to the server so that you can configure it.
5 minutes later.
Okay, so eventually I can SSH to the server. I'll accept the public key, put in my password, and there you go. I'm logged into my Ubuntu server. You can see this is Ubuntu 24.04.2 LTS. Okay, so I'll clear the screen. First thing I want to do is sudo apt update. So I'll update the references on the server. Now you don't have to do this, but I'll do an upgrade just to upgrade the server. So sudo apt update, sudo apt upgrade, basic server related stuff, nothing to do with WireGuard, but simply get the server ready for the WireGuard installation. I'm going to keep the local version currently installed. Okay, so server's upgraded. I'll clear the screen. And now we can use the command sudo apt install WireGuard-y. Now, I'm running as root here, so you don't need to do sudo, but just out of habit, I've done that. But if you're not logged in as root, probably recommended that you don't. You would use the command sudo apt install WireGuard. Okay, so WireGuard has been installed successfully. It's a very simple installation. On their website, highly recommend that you look at their website. They have a quick start guide. So they show side-by-side videos of how to set this up. They also give you various commands that are used and what those commands do. I'm going to explain that all here. So this will hopefully simplify the process for you. WG is the command that you need to remember. So WireGuard. In this example, I'm going to be generating a private key and storing that in the file called private. So just before I run that command, ls shows me that a private file doesn't exist. So at the moment, there are no files on my server in this folder or directory. So what we're going to do here is use the WireGuard command. WG is the command that we're going to use the whole time. We're going to generate a private key and store that in the private file. So if I type ls again, notice that file exists. Now we are warned that this file will be accessible to the world, and we should use better security on the file. So if I do ls-l, notice read is available for everyone, and we don't want that. So I'm going to use sudo change mod, and forgive me for typing sudo the whole time, it's just out of habit, 600, and we're going to change the permissions of this private file. So ls-l again, notice read write is only available for the owner, so root in this example. Now you can view your private key by catting that file. I'm obviously going to blur this out for this video. You could view your own private key that way. I'll clear the screen here. And now what we're going to do is use WireGuard to get a public key from the private key. So there's our public key. And you could see that this is the public key that you would share with the whole world. You would obviously only want to share your public key with yourself. So in this case, with your client device, my Windows laptop for me. But notice we have a public key and a private key now. WG would show us if the config is ready. At the moment, nothing is displayed because we still have to set up our WireGuard interfaces and the like. But you could view your public and private key that way once it's configured. But now what we need to do is bring up a new interface called WG0. So WireGuard 0 interface. So before I type that command again, IP address shows me that I only have an Ethernet 0 interface and a loopback interface. I don't have a WireGuard interface at the moment. So this command, IP-link add, is going to allow us to add a new interface to the server. This is a WireGuard interface. So the type is WireGuard. So up key, IP address, notice we now have a point-to-point WireGuard interface. The number is 0. You could add multiple WireGuard interfaces if you wanted to. So 1, 2, 3, 4, etc. But we've got one in this example. Now this is an IP interface. So we need to add an IP address to this interface, so the WireGuard interface. The IP address that we're going to use here is 10.0.0.1/24. Now this is a point-to-point interface. You don't need to allocate 254 IP addresses to that interface. In my example, I'm simply following the documentation from the website, but you could obviously restrict that interface size to something less than that. So notice on the WireGuard video, they are allocating 10.0.0.1 and 10.0.0.2/24 to the interfaces, and I'm simply going to do that as well here. So notice IP address now. This WireGuard point-to-point interface now has this IP address 10.0.0.1/24 allocated to it. Now we have to set the private key for this WireGuard interface. So we're using the WireGuard interface. We are setting the interface, which is WireGuard 0, to use this private key. And the private key is the private key stored in this file called private, which we previously created. So again, my file is there, and I've shown you the private key already. So IP address now, we can see our interface, WG now, shows us that this interface is using this public key. The private key is hidden because I changed the permissions of the private file. In their video, WG actually shows their public key and their private key, and then the listening port, I'm hiding the private key because I changed the permissions to make it more secure. Okay, so the next thing to do is bring the interface up. So before I do that, IP address again, the interface is currently not up. So notice state is down. We don't see something like this on our Ethernet interface. So again, the command is IP-link set WG0 up. IP address again. Interface is now up, whereas previously it wasn't. Notice there was point-to-point, no ARP. Here we have point-to-point, no ARP, up, lower up. So interfaces come up now. So WG notice the listening port, which we didn't see previously. So WG shows us our public key for this WireGuard interface. Private key is hidden. Listening port is 34233 in my example. In your example, it would be a different number, but for me, it's 34233. Okay, so we've completed a bunch of configuration on the server. Now we need to do something on the client. One of the next steps we have to do on the server is add the public key of the client to the server. So I can't do that until I've created the public key on the client. So on my client device, I'm going to open up a browser. I'm going to go to the WireGuard website, go to installation, and I'm going to download the software for Windows because this is a Windows laptop. So you simply need to download the software. It's only 83K in size, and then open it up. So I've actually downloaded it previously. So I've got 2 installation files, 86 kilobytes, so quite small. So I'll double click on the executable file, say yes to allow WireGuard to make changes. Software is now being downloaded and then installed. So installation starts, and there you go. Very, very simple. Now, this can be confusing. If you click on tunnel, you need to import a configuration file. What I'm going to do is click on the little drop down and then add an empty tunnel. Notice here is my private key and here is my public key. So I'm going to need to copy this public key onto the server. But before I do that, I'll set up the client in the meantime. So this is going to be my Dallas private VPN. You need to add some configuration here. So you need to specify options such as the address that you're going to allocate. So remember on the other side, we have an IP address of 10.0.0.1/24. So on the client, we're going to use 10.0.0.2/24. You could use /30 here as an example. It's a point-to-point link, so you don't have to allocate so many addresses to that subnet. But I'll just follow their documentation once again. DNS is going to be 1.1.1.1. We need to specify the endpoint of the tunnel. So back on my server again, WG, this is the port number 34233. So 34233. And the IP address of the server is 96.126.127. So what's nice here is if you type this incorrectly, it shows up in red until you get it right. So 96.126.127.28. So that looks good. Allowed IPs, I'm going to set to everything. Keep alive, I'm going to set to 25. But what I need is the public key. So on the server, I'm going to simply copy this information and save it to a file. So what I've done is copy the details to a USB drive and I've put it into the laptop. So now on the laptop, I can get those details. So I'll copy the public key to the client. So clear this. So there's my public key. What I need to do as well is copy the public key of the client to the server. So I'm going to save that to my USB drive. So now we can use the command WG set WG0 set peer and the peer's public IP address. In other words, the laptop. This is the laptop's public IP address and allowed IPs will be 10.0.0.2. So I'll just make this smaller. There's the full command again. We are going to allow 10.0.0.2 through the VPN. And that once again is the client's IP address on the laptop. So what we're doing here is we're exchanging the public keys between the two devices. The server's public key is copied onto the client. There it is over there. And the client's public key is copied onto the server over here. So both devices have each other's public keys. So I'll save this. You can create a kill switch. I'm not going to do that in this example because I'm remotely controlling this laptop from my Mac. So I'm going to click save there, but you probably want to do this. So untunneled traffic will be blocked. So you create a kill switch so that all traffic goes through the VPN. So again, WG on the server. Notice we have a WG interface. We have the public key of the server. We have the public key of the client. We have the IP address of the client that's allowed to send traffic through the tunnel. This is the listening port of the server. So on the client, I'll click activate and hopefully if everything works, we'll have a connection, which we do. We can see data is being received and sent. We can see that the tunnel is activated. We can see the IP address, etc. So what I should be able to do is ping a website, let's say google.com, and if things are working properly, we'll be able to connect to the server. Now, that's a worrying thing here. Notice it shows IPv6. So that tells me that IPv6 is running on this laptop. I'm going to want to disable that because I want to hide my IPv6 address. At the moment, however, if I go to whatsmyipaddress.com, I'm not going to see stuff properly. We still need to do some configuration on the server to hide our IP address. Our server's IP address, again, is 96.126.127.28. IPv6 address shows that is my local IPv6 address. I'm going to want to hide that. So on my PC, if I type ipconfig, this IPv6 address is shown on whatsmyipaddress.com. We're told that an IPv4 address is not detected, so that's not right either. My ISP is shown here, SpaceX. So something's not working. So to fix this, we need to do a few things. The first thing I want to do is get rid of IPv6. So I'm going to deactivate my VPN. I'm going to go to my network settings in control panel. So network and internet, network and sharing center. I'm going to go to my adapters. And what I want to do here is disable IPv6 on my network adapter. The reason why is I want to enable NAT on the server where we NAT IP version 4 addresses. At the moment in my VPN, I have got this 10.0.0.2 IP address. I'm going to want to NAT my IP addresses so that when I go onto the internet, the IP address that's shown is actually my server's IP address rather than my IP address. I'm not going to run NAT66, in other words, NAT for IPv6. Generally, you don't use NAT in IPv6. But the problem with that is you'll be able to see my IPv6 address. It's shown right over here. And my location is shown as in London. I want to hide my IPv6 addresses. The best way to do that is to simply remove IPv6. So I'm going to disable IPv6 on that network adapter. I have got another network adapter in this laptop, and I have disabled IPv6 on that as well. I prefer to use IPv4 because I know I can NAT that very easily on the server. I don't have to run NAT for IPv6 and NAT for IPv4. I'll simply use IPv4 and NAT that so that my IP addresses are hidden. Okay, so on the server, what you'll also notice is IPv6 is not enabled or installed on the server. The only IP address I have is IPv4. I want to get rid of IPv6 entirely. Okay, so we have to do some additional configuration on the server. And one of the things we need to do is allow forwarding of IP traffic on the server. That's why I didn't see an IP version 4 address when I went to whatsmyip.com. I need to enable the forwarding of IP traffic on the server. So that's now being set. And we can use this command, sudo sysctl-p, or in my example, I don't need sudo, to automatically allow this without changes. Now it's just a copy and paste mistake there. So running the command again, notice that's been enabled without a reboot. So to see how traffic gets to the internet, let's see how traffic gets sent to quad 1. Notice the source interface is Ethernet 0 as expected. So we're using the IP address on our Ethernet 0 interface to get to that server. So that looks good. Now, we want to set up NAT so that we can hide all the traffic from the client. So if I did this now without enabling NAT, so I'm connected to the VPN. So now if I try and go to whatsmyipaddress.com, notice nothing is working because we're using a private IP address trying to go onto the internet. So we need to enable NAT. So I'm going to use this command to enable NAT. Here's what the options mean. -T or -T means we're going to use NAT. -A, post routing, adds a rule to modify outgoing packets after they routed. Outbound interface is going to be Ethernet 0. So NAT will be applied to traffic going out of that interface. -J or -J masquerade replaces the client's IP address with a server's IP address, so replies can come back correctly. Okay, so I'm going to type that now because otherwise we'll have this problem where the client can't get access to the internet. And what you might have noticed is immediately the client's browser was refreshed and we were able to access the internet using this IP address 96.126.127.28, which again is my server's IP address. There's the IP address on Ethernet 0. I have disabled IPv6 because I want to send all the traffic through the VPN. We're using IPv4. I want to NAT this IP address onto the server's IP address, RFC 1918 address, non-routable on the internet. We want to NAT it to the server's public IP address, send it onto the internet, get the traffic back, NAT it back to the client so that we have internet access. You can see things are now working the way they should. What's my IPaddress.com says that I'm in Dallas, Texas, even though I'm not. IPv6 is not detected. This is my IP version 4 address. According to this, I am in the Linode network. That's not actually the ISP I'm using. I'm using Starlink in this example. Now, from a speed point of view, this really depends on your internet connection speed and the server that you're using. So I'm on Starlink. It varies, speeds vary, but notice I'm getting almost 100 megabits per second at the moment, so 98 megabits per second. You could get much greater speeds if you have a fiber connection from your device or another high-speed connection, and you provision a big server. So again, here, I'm only running a 2 gig server. According to Linode, I should be getting 2 gig out, 40 gig in. So that's more than enough for what I'm doing, but you may need to use a dedicated server. You may need to allocate a Foster server, more beefy server if you're sending a lot of traffic. But in my example, that's fine. I'm happy with that. So again, I am on the VPN. VPN is set up properly. Okay, so it was as simple as that to set up a WireGuard VPN. Once again, we did some configuration on the server. You can see that configuration by using the WG command that shows us the public key that was generated from the private key. Private key is hidden here. The listening port is this. Our peer, which is this laptop, has this public key, which is shown here on the server. The allowed IPs is this. Handshake is that. Traffic that's being sent and received is the following. On the client, again, public IP address, listen port is this, IP address is this, DNS server is this. We're connecting to the server that has this public key. Allowed IPs is everything basically. Endpoint is this IP address. So quite easy to set up a client and a server to use WireGuard. Fantastic way to set up a VPN. Now, something that's really important to do is to make your changes persistent. You don't want to set up your WireGuard server and then when it reboots, you lose all of your changes. So you're going to want to make your configuration changes persistent. So the first thing we're going to do is install IP tables persistent. So we're told current IP tables rules can be saved to the configuration file etc IP tables rules.v4. These rules will then be loaded automatically during system startup. Do we want this? And the answer is yes. Same for IP6. And there you go. Software is now being installed. We now need to save our current netfilter or IP tables rules so they are loaded on system boot. So there you go. IP tables version 4 and version 6 are saved. Okay, now WG shows us our WireGuard configuration. We can see our public key, we can see the listening port, we can see the peer information, but we want to save that configuration because when the server reboots, that's all lost. So the way we're going to do that is use WG to show our config, and then we're going to pipe that to etc WireGuard WG0 config. So before I pipe that, just to show you the output. So WG show config WG0. We can see our private key, which we're going to hide for this video. We can see our listen port. We can see our peer's public key, allowed IPs, and the endpoint IP address, etc. So what we're going to do again is pipe that to etc WireGuard WG0 conf. So if I cat that file, you can see our configuration once again. So we want to make sure that our configuration is not just stored in memory, but it's also stored in a file. And the WireGuard configuration files are stored in etc WireGuard and then the name of your interface, so WG0 in our example, because again, our WireGuard interface is WG0. Now we need to use WireGuard quick when the system starts up to actually create the WireGuard interface. Having the configuration is fine, but when you reboot the server, the configuration won't be there. So we're going to use sudo systemctl, or in this case, because I'm root, systemctl enable WG Quick. WG Quick allows us to build the WireGuard server configuration. When it boots up, an interface we're going to build is WG0. The next command we're going to use is systemctl start and the WireGuard configuration. Now, you may have an error when that runs. Don't worry about it. The most important command is this command, so that when the server reboots, our configuration is still there. So what I'll do as a test is reboot the server. On the client, pings are succeeding. VPN is up. If I search whatismyipaddress.com, notice I'm in Dallas. So on the server, I'll reboot it. Connection is lost. So as you can see on the client, pings are now timing out because the VPN has dropped. On my backend, I'll open a console. We told your Linode isn't running or another session is already active. So that's because the server is booting up now. Over here, we can see it's actually showing offline while it's rebooting. Okay, there you go. It's now running. So I'll click on it and look at the console. And you can see now that it's booted up and is asking for login details. So hopefully our pings will start succeeding. And there you go. You can see it was timing out and suddenly it started succeeding again. On whatismyipaddress.com, you can see we are still in Dallas according to this. But there you go. Scrolling up here, you can see pings were succeeding, rebooted the server, pings started timing out, server came back again. Pings are working once again. So again, make sure that you set up persistency on your server so that when it reboots or it's shut down and then you turn it on later, that your changes are persistent and aren't lost. What I'm going to focus on now is how to lock down the server and make it more secure. So the first thing we're going to do is allow non-root access and then block root. So I'm going to create a user called David VPN. We'll set a password for that user. So we've updated the password for the user. We'll add the David VPN user to the sudo group and keep the other groups as they are. And now what we can do is set up this user so that it can only access the server using a public key. So rather than using a username and password that can be hacked by a brute force attack, we're going to use a public key to access the server. So on my MacBook, I'm going to generate a public key and private key. You're going to want to set a passphrase to give you extra security. So I'll enter that and notice a public and private key have been created for me. So my public key is stored here. This is the fingerprint of the public key. Highly recommend that you use Linux or Mac to do this part of the configuration. Windows gives a lot of problems. You could do it with Windows, but I prefer using Linux or Mac OS to do this. Okay, next thing we need to do is copy that public key to the server. So my server's IP address again is this. So I am copying my public key to the server. I'll put in my password. So the number of keys that have been added is 1. We're told that we can check whether we can SSH to the server using the keys that we've created. So what I'll do is open up a new tab, SSH to the server, and notice now we're not asked for our password, we asked for our passphrase for the public key. So I'll paste that in, and there you go. I've been able to log in. Notice the prompt has changed. We can see that we are David VPN. Both root and David VPN are logged in, but I'm currently David VPN. Again, who am I? Shows me that. You can see the prompt is different to our prompt when we root. Here we root, and here we are David VPN. So now we can log into the server as David VPN without a username and password. So again, if I SSH to the server as David VPN, 96, 126, 127, 28. We are not being prompted for our username. We are being prompted for our passphrase for the key. So not username. I could still SSH as root. And notice the difference here. I'm asked for the root's password. We want to lock this down as well. So we want to remove root access like this so that no one can log in as root. They have to log in as David VPN with David's private key. I'm the only one with that private key, so I'm the only one that can log in. So notice the number of public keys added is 1. So I can SSH to the server and I will be able to log in because I have the private key. So only David VPN can log in. It's expecting that you log in with your private key. So I won't go into the details of how that all works, but basically the only person that can log into the server now is the person that has that private key, which is me. No one else will be able to log in. Okay, so let's remove root access to the server. So I'll do that as root at the moment. So I'm just going to use nano to make this easy. So nano etc ssh sshd config. Now before I make changes to that file, what I'll do is copy that to a backup file. And now I'll make changes to the file. A whole bunch of options here. You can change many things. But notice here, permit root login. We're going to say no. No root login is going to be allowed. Now, rather than trying to find these entries individually, I'm just going to use Control W to search for something. And I'll search for 22. The port I'm going to change to port 222. Now, if someone is using Nmap to scan your server, they'll be able to find that the server is listing on port 222 instead of port 22. It's not a failsafe, but we are just adding things to make it more and more difficult to access the server. I'm going to search for password authentication. We are going to disable password authentication. So password authentication is going to be set to none. Pub key authentication, we're going to set to yes. So that's now set to yes. Authorized keys, we are going to set to our authorized keys file. So remove the comment option here. So I'll exit out of that and save the file. What I'm going to do is stop the SSH socket. That stops the socket-based SSH service. I'll stop that from starting at startup, which might interfere with our configuration changes. We're going to enable the regular SSH service. And then what I'll do now is restart that service so that our changes take place immediately. Okay, so what that means is if we try and SSH to the server as root, notice connection is refused, firstly because we're on the wrong port. So I'm going to have to specify a port of 222 now. And notice permission denied public key. I cannot log in as a root on that server any longer. And what I need to do is use the David VPN account username to log in and have access to the private key for the David VPN account. And in addition, I need the passphrase for that key. And only then I can log in. So notice I'm logged in now to the server. And back on my client, I can get access to the VPN. Now there's always a risk having a server like this on the internet. Someone could try and hack it. This is a public IP address. But what we've done now is remove root access. So this no longer works. So again, if I try and SSH to that server, it doesn't work. I have to remember to use the right port. And again, this is going to fail because I don't have a public key. I can't log in as any user. I've got to log in as the right user with the right public key. So I've got to have the right key to be able to log into the server. This is much more secure than the defaults. Now, as an ultimate solution, what you could do is power off the server when you're not using it and only turn it on when you want to access the internet using the VPN. The problem with that obviously is you have to connect to Linode or whoever your cloud service provider is using your public IP address, which anyone could find out about, turn the server on and then start the VPN, which you might not want to do. You might want to run this permanently. So it's always available that you can set up a VPN. That's your choice, however. Now on the WireGuard website, we told why we want to use it. I mean, the big reason here is it's open source. Huge reason to use this. Open source software is great. We also told that it's extremely simple, yet a fast and modern VPN that utilizes state-of-the-art cryptography. It's faster, simpler, and leaner, and more useful than IPsec, which has been around for years, avoiding a lot of the headaches that we have with IPsec. It intends to be considerably more performant than OpenVPN. So WireGuard is designed as a general-purpose VPN for running on embedded interfaces and supercomputers alike, fit for many different circumstances. It was initially released for Linux, but is now cross-platform, supported on Windows, Mac OS, iOS, BSD, Android, etc. It's widely deployable. In this example, I'm running it again on a Windows computer, but you could run it on a separate device if you wanted to. It's also very highly regarded. Some people might even regard it as the most secure, easiest to use, and simplest VPN solution in the industry. Now, you can read the stuff on the website yourself, but big reasons to use it is it's simple to use. It's using public key cryptography. All you're doing between the devices is sharing their public keys, and everything else is handled transparently by WireGuard. It's even capable of roaming between IP addresses just like Mosh. So much better than, say, IPsec, where you do a point-to-point tunnel and you have to know the IP address of the other side. It's cryptographically sound. Notice it uses state-of-the-art modern cryptography protocols such as the following. It's got a minimal attack surface. It's been designed with ease of implementation and simplicity in mind. Very few lines of code when compared to other solutions. Very high performance. It's gone through an academic process resulting in a technical white paper. Basically, great solution. One of the advantages of running your own private VPN is you're in control. If you don't log stuff, it's not logged. You have full control of your solution rather than relying on someone else. But to do this, you need a good solution, and WireGuard is that. Fast, easy to set up, no leaky logs by default, etc. You have full control over your solution, and you can again configure it to use any UDP port, making it harder to fingerprint. You can make it even harder to track you if you use obfuscation proxies such as WireGuard plus Cloak, etc. So great solution. Probably worth you giving this a try and seeing if you like it. I think it's great, and that's why I'm showing it to you in this video. Rather than relying on an older solution, older software, use something modern protocols, very good, very fast solution, very easy to set up, uses modern cryptography, gives you roaming, etc. You're in full control of the solution. Okay, so I've covered a bunch of stuff here. I've shown you how to set up WireGuard. I've shown you how to lock down your server, make it more secure. Hopefully this has helped you. Let me know in the comments what you think. What did I miss? Did I make any mistakes? Let me know. I've put the commands in the video description so that you can have access to those to make it easier. But hopefully this video shows you how to easily set up a WireGuard VPN so that you can have your own private VPN and not rely on someone else who perhaps doesn't clear the logs or keeps data about you. I'm David Bombal. I want to wish you all the very best.